All right, I think we might as well get underway. And anyone who is late can join us just a little bit later. So, good day, good evening, good morning, whatever the case may be, where you're joining us from, folks. Thank you for being here today. So my name is Alex from Dbvisit Software. I'm the head of development for the company, but we're just organizing this webinar. So the real star of the show, I'll introduce you to in just a moment. The reason that we thought we would do this webinar is because, Postgres deployment for Oracle DBAs is because Postgres is an increasingly important subject in Oracle communities. And we would know because we've been in Oracle for over 15 years. So I know it's a hot topic and something that people discuss all the time. So just before we get underway, a quick little bit of housekeeping. We do have translation services available for you in this webinar. So if you find it easier to follow along in something other than English, please click the button Show Captions down at the bottom and select whatever language you prefer. Please put all of your questions in the Q&A section. Don't wait until the end. We're gonna, as questions build up in the Q&A, we're hopefully going to address them towards the end of the webinar. And once we're done, don't worry, the recording will be made available to you. So anything you miss or anything that I talk over too quickly, you'll be able to catch up on once we're done. So once again, there's a particularly flattering marketing photo of me. My name's Alex. Dbvisit are database disaster recovery experts. We've been in the business for over 20 years, primarily on Oracle and now on SQL Server and Postgres as well. But today is not about me for a change. It's not about Dbvisit. The real star of the show is this gentleman over here, Umair. Say hi, Umair.
Hey.
So Umair is a 20-year-old veteran of the Postgres community and someone that we've become very friendly with over the last few months. And he is going to launch us on a very exciting and interesting journey today with this webinar. So I will hand it over to him. Let's get into it.
Excellent. Thank you very much, Alex. It's a pleasure to be here. And let me just figure out how to share my screen and we can start moving. All right. Let me know if you can see the title slide.
That's perfect. Yep, you're all good.
Excellent. Okay, great. So yes, thank you, Alex, and thank you, Dbvisit, for having me here. It's always a pleasure speaking about Postgres, especially to an audience that is looking to cross-train and improve the skills in a different technology. I've been in the Postgres space for a while, and sometimes we get to have blinders on, not really knowing what's going on in other parts of the world and in other technologies. An excellent opportunity to talk to DBAs from coming in from other technologies. So yeah, this session is going to be focused on Postgres deployments and the typical areas that you need to be mindful of as you deploy. It's oriented towards Oracle DBAs, but I imagine that any newbie coming in from any other database technology should also be able to benefit from the content that we're going to discuss today. The 6 broad topics that we're going to be talking about, the overview of installing and deploying the database, the configuration files that you need to be mindful of, how to set up your database for disaster recovery for high availability, some little sneak peek into the Postgres ecosystem and the tools and extensions that are available to us, and what the popular cloud providers make available in terms of Postgres technologies. So first off, the overview of installing and deploying. Now, first off, the minimum hardware requirements for installing Postgres, they're fairly small. I mean, you can run it on a Raspberry Pi. You can run it on edge nodes for IoT. It has pretty bare minimum requirements when it comes to hardware. Just a single 1 gigahertz CPU, a single core would do 2 gigs of RAM would be enough. less than half, or half a gig of a hard disk should also be enough. Of course, this doesn't mean that this will make your database blindingly fast, or you can store loads and loads of data in it, but you can install and reasonably use Postgres on edge devices, even on a Raspberry Pi with very, very little hardware resources available.
That makes for a nice change from Oracle. We're used to, in the Oracle world, we're used to pretty significant hardware requirements.
Yeah, and this might also be one reason why Postgres makes it so easy to get started. You don't really need to invest a whole lot in infrastructure and hardware, and yeah, so fairly low barrier to entry.
And of course, the database itself is free as well, which is quite nice.
Yep, that's true. That is certainly true. So one thing that I want to explain before we get into some more details is what we mean by a repository. What it essentially means is that it is a central location, a place where we store a collection of software packages. And depending on the operating system that you're running your database on, the package manager for that OS needs to be told where to get software from. And that's what the repository is. So if you're using Linux or Windows or Mac, each has their own package manager, and you need to be able to tell it where to get Postgres from. And that is why the concept of repositories exists, and that is why the Postgres community maintains these repositories. And the repositories that are provided by PGDG, well, actually, let me just first define what PGDG means. It's the PostgreSQL Global Development Group, which is the official name given to the global community of enthusiasts and developers and contributors that come together to make this database. So, one clear differentiation between the community and commercial interests is that in PGDG, when I work with the global development group, it is on my own time. It's a volunteer effort. It's not a paid effort. It's the open source community that's coming together to do what we are passionate about. And there are a few repositories that are provided by the PGDG. I've listed them out over here. For Linux, we've got 3 main repositories. The apt repository is for package managers for Ubuntu, Debian, and Kubuntu, and you can access it at apt.postgresql.org. The Yum repository is designed for package managers of the Red Hat family. So, the Red Hat Enterprise Linux, CentOS, Fedora, Rocky Linux as well, and you can access it at yum.postgresql.org. And for package managers of BSD, PGDG provides ports repository that you can use to install Postgres on BSD. For the Mac, Mac ports is provided, and you can access it at macports.org. Again, to emphasize, these are the repositories that are managed and provided by the Postgres community. Besides these, there are a few other options as well, details of which you can find at this URL right here, postgresql.org/download. And you can navigate to it when you go to the Postgres website anyways. It's a very prominent download button. And over here, you'll see some other options. Now, these are options that are provided from outside of the PGDG. These are at times commercial interest, at times third party, and other communities that come together to provide other means of installation of Postgres. So one very prominent OS that was missing in the previous slide is Windows. PGDG does not provide a repository for installing Postgres on Windows or a native installer for Windows. That is provided by EDB, which is a major player and a software provider in the Postgres space. And you can access this Windows installer at the same link that I have listed at the very top. EDB also provides an installer for Mac, and you can get a native app by the name of postgres.app for the Mac, and the Mac binaries are available on Homebrew if command line is your preferred option.
So
native installer.
I'll just jump in with one thing, Umair, from the previous slide, because I imagine that Oracle guys like myself are immediately going to have a question, which is Oracle Linux okay? And can you run the Yum package on Oracle Linux? And the answer, of course, is yes. So the standard Red Hat Linux package you can run on Oracle Linux just fine. In fact, as I just answered in one of the Q&As, it's actually one of our test environments is on Oracle Linux. So yep, go for it. And the other quick question we had is, what's EDB? I know in your world, Umair, that's like, what's EDB is like, who is Jesus? But so EDB, it stands for, is it Enterprise DB, Umair?
Yes,
Is that right?
yes, Enterprise
So
DB, yes.
so EDB, folks, is the name of a company. It's a proprietary name. It's the name of a company who put out a very, very popular, very widely used kind of version of Postgres, which is called Enterprise DB, which is called Enterprise. Is it Enterprise Postgres? Is that a fair
Yeah.
way to call it?
So yeah, so the fork of Postgres that's provided by EDB is called EPAS. So that's Enterprise Postgres Advanced Server.
That's the one. Yeah.
Yeah.
And it's based on the Community Edition. It has a whole bunch of utilities and services and things that you can access. You will need a service contract with EDB themselves, which carries a bunch of advantages or disadvantages depending on how you look at it. But that's what it is. So EDB stands for Enterprise DB, and it's basically like an alternative commercial edition of Community Postgres.
Thank you for clarifying that, Alex. As I said in the beginning of the conversation, that at times we have blinders on, and I just carry on assuming that everybody knows what I'm talking about.
That's what I'm here for. That's why you're presenting this webinar, Umair, and I'm just here like sticking my hand up and going, "Ooh, what's that? What's that?" The other thing. We just had a question literally 5 seconds ago, and this is literally something that you and I spoke about before the webinar as well, which is, I told you this was going to come up, which is why does the Community Edition, why doesn't the Community Edition provide an installer on Windows?
So yeah, it's a very good "I told you so" moment for you, Alex.
There's plenty more to come, I'm sure.
Yeah. So the thing is that with the open source nature, most of the open source communities around the world are kind of based within the open source ecosystem, and in the OS world, that is mixed-based platforms. So anything that is based on Unix, which includes, the Debian family, the Red Hat family, the Mac family of operating systems, that is something that the open source communities are generally aligned on. At one point in time, and this was very long ago, more than 15 years ago, there was a build farm by the Postgres community that was focused on providing binaries for Windows. But the overhead was enough, and there weren't enough volunteers, willing to work on the Windows OS. It was shut down, and it's been more than 15 years that it's not around, and it's not providing those binaries. Also, in our experience, in my experience as well, there are very few production deployments of critical databases of Postgres on Windows. Most of them are on Linux, even Mac. It's very few and far between. But increasingly, as organizations move from other databases to Postgres, we have started to see a demand of Windows coming in. So who knows? In the future, maybe PGDG does bring that up again. But for now, the only Windows option is from EDB.
Thanks for that. Yeah, we've just anecdotally, we have heard of a few Windows commercial instances, and they're fine. They run as well as anything else. There are subtle differences between Linux and Windows versions of Postgres, but to be honest, they're quite we'd need to be getting into the advanced kind of areas in order to discuss them. The short answer is that Postgres is equally viable on Linux or Windows, or indeed even Mac, as Umair said.
That is true, and we certainly have worked on critical Windows deployments for Postgres as well. Some critical security-related government or organizations are running Postgres on Windows, and successfully so. It's just that it's a very small percentage compared to the Linux deployments. Right?
Yep, that's right. Just before this slide is popular. Just before we move on, Umair, is a question that you'd be better off answering than I would. Question is it possible that to install EDB packages like PEM?
It certainly is possible. For the most part, however, what you are going to do is that you get a 30-day trial from EDB to get access to their repositories. And you can try out different packages like PEM, and make sure that you're happy with what you see. In order to use it in production and for your day-to-day database work, you do need to get a subscription from EDB. That's part of the license agreement. So this is proprietary software that we're talking about. You can try it out, but you need a license to use it in production.
Excellent. Thanks for that. As we, I expect there'll be more questions about EDB as we go through. I don't want to get hung up on it, but I mean, just as a kind of as a quick comment for everyone on the call, folks, like in the Postgres world, EDB is kind of as close as you get to an Oracle-like relationship. They have a whole bunch of tools and a whole bunch of very valuable services to offer you, but it's kind of like a corporate style relationship. So you get in touch with them. Pricing's a bit opaque. It's sort of what can you afford type of model, and they do like to, if you choose to go with them, and in some cases that's a perfectly appropriate choice. They do like to kind of lock you into their ecosystem.
That is correct. And there are, as you'd mentioned earlier, Alex, there are pros and cons to it. EDB does have a very strong ecosystem of very reliable software, as well as good skills of engineering to back it up with. By the way, Stormatics is not only a reseller, but also an implementation partner with EDB. So we work with a lot of EDB customers. And in case somebody from on this call has more questions about EDB, I'm happy to answer them offline. But because the session is about Postgres, not EDB. There you go.
Let's carry on.
Moving on from Mac to Solaris, when I started working with Postgres, this was more than 20 years ago, Solaris was one of the popular platforms. Increasingly, however, it has grown, less popular for production deployments. You can still use Postgres on Solaris if you have that's the OS of choice, and if you are using hardware that is somewhat older like that, and you can do it from source. Essentially, we don't get binaries for Solaris anymore, but you can install and run Postgres from source on Solaris. Then there are packages, much like LAMP stack was made very popular with the MySQL combination. We have a similar stack provided by Bitnami for Linux, Mac, and Windows, and the stack consists of Apache, PHP, and Postgres. You can download and use that. A container is available for Postgres at Docker Hub. And there are Kubernetes operators that are provided by a few different organizations and communities. Some of them are listed out. This is not a comprehensive list. I'm sure that I'm missing at least a couple of names in there. But Cloud Native PG, at least if you go by GitHub stars, that's the most popular, followed by Zalando, and then by Crunchy Data, and then Percona. So depending on what OS you want to deploy on, if you want to do containerized or Kubernetes version, you have these options available. Okay, moving on. Just an example of how to use the repository that I referred to a couple of slides back. This example is specific to Ubuntu because every system will have its own command. But the first thing that you do is install the common scripts and files, and you can do that by a sudo apt install Postgres common. Then you need to enable the repository for the package manager. And the simple command, there's a simple shell script that is installed as part of the common package. And you can run that shell script app.postgresql.org.sh, and that will enable the repository for your Ubuntu package manager. And once that is enabled for that package manager, just update the packages list by running a sudo apt update, and then you can install Postgres. If you run this command right here, sudo apt install Postgres without specifying any version, it will by default pick up the latest version, which currently is 17. Or you can specify a version by saying hyphen and then put the version number in front. So it could be, if you want to, let's say, install Postgres 15, you'll say sudo apt install PostgreSQL hyphen 15, and that will install version 15. And once the installation is done, this is the typical file paths of the important directories and configuration files that you need to be mindful of. By default, the data directory will be under /var/lib PostgreSQL 17/main. 17 over here is assuming that you installed the latest version. This number will change in case it's a different version you have installed. The configuration files are going to be present in etc PostgreSQL 17/main, and the binaries are going to be under user lib Postgres 17 bin. This is just so that you know where the typical files and directories exist on Ubuntu after installation. By default, the user that is created for the database is Postgres. And for security, you want to make sure that you are not using the default user and the default password, because that will make it extremely easy for anybody to break into your database. You don't want to do that. You could also opt for making a honeypot and call it entrapment or something. But just make sure that you don't run the defaults. Create a user other than Postgres. It could be Yoda, just putting a name out there. Switch to that user and create a new database for yourself, and make sure that the system scripts are now using this new user to start the database. You can go in and modify them. I'm not going to go into the details of how to do it. I'm sure that a combination of Google and ChatGPT can get you there. You can.
No, you're just throwing out suggestions and then not following through with the full advice.
Yeah. Well, AI will take you a long way. It will not take you all the way. So once you reach there, feel free to get in touch and we can help you. There you go. I went all the way.
Perfect.
So once the scripts are modified, you can log in as this new user, Yoda. Now, you want to make sure that any connection to the database is logged. So there are configuration parameters, log_connections and log_disconnections. Set them to true, and the database will log every time a user connects or disconnects from the database. Because you'd want to make sure that the default user is not used for any malicious purpose, revoke all privileges from the default user. And in order to create that honeypot, you can allow the login without password from the configuration file. We'll talk about that configuration file in just a minute. Set an alert for logins related to the Postgres user. And in case anybody does log in, try to log in, you'll be able to track that IP and know that there has been a malicious attempt on your database. So this is, just a quick way to create a honeypot. Absolutely optional. You don't have to do it, but best practice does say that don't rely on the default user and the default password. This would be a security risk. Step two in the agenda, talking about the configuration files, I alluded to talking about pghba.conf, and that is one of the things that we are going to be talking about. Two main files that you need to be mindful of that are deployed as part of your installation of Postgres. It's postgresql.conf, and this is related to configuration parameters that control performance of the database. And pghba.conf, this is authentication configuration, and that controls the security of your database and who is allowed to access the database and how. Let's talk about postgresql.conf first. These are a few example parameters that you can set within the configuration file. This is not a comprehensive list at all. By any means, the comprehensive list is going to be very, very long. But this is just to give you an idea of the kind of parameters that you can set. The very first is shared buffers. This is the amount of memory that Postgres allocates for caching data and indexes. Typically, the best practice recommendation is to assign 25% of your system memory to shared buffers for caching data. This can go as high as 40% for very heavy transactional workloads. I generally prefer to stay closer to 40%, but keeping it somewhere between 25 and 40 is the best practice. Anything over 40 is going to consume too much resources, and anything less than 25% means that you're not leveraging your database to the maximum. So that is kind of the range that you need to aim at. Work_mem, this controls the amount of memory that is allocated for operations within queries. So this could be sorts, aggregates, and this amount of memory is allocated to every operation, and it can be allocated to single threads as well if a particular query is multi-threaded. So let's say you run a query and the Postgres query planner decides to use 5 threads and sorting is done in 5 threads, then 5 times the work memory is going to be consumed by that particular query. So you have to be very careful in allocating because this can multiply very, very quickly in a heavily concurrent database. A typical rule of thumb is to look at the total memory available, subtract out the shared buffer settings, subtract out the OS overhead that you expect to get, and then you divide it by the expected number of concurrent queries, and you set workmem to that. This is, again, just an idea and a starting point on how to set this. You need to continue monitoring the database and ensure that it's not the setting is not too low nor too high.
Umair, what's the default value, if there is such a thing?
If I remember correctly, the default is at 25% of shared buffers, if I recall correctly. But yeah, don't hold me to it.
So that means that the total work memory is basically equal to the shared buffer size, right?
I don't understand that. Sorry.
Oh, sorry.
So let me elaborate. 25% of shared buffers, which is 25% of system memory.
Yeah, that's me. Sorry, that's me remembering settings from our test environments.
Okay. Yeah, so that's the default, and the defaults, typically on especially some infrastructure that is heavy duty hardware, the default settings need to be tuned a little bit. So yeah, it's good to take a look at these settings and make sure that they're set appropriately. Much like workmem is assigned to certain operations run by the users, maintenance workmem is the amount of memory that is assigned to maintenance tasks of the database, right? It could be vacuuming of the database, the index maintenance, analyze and database statistics maintenance, because the database has its own overhead This is the amount of memory that is assigned to the database, and it typically starts at 5% of the available system memory. And you can then monitor and try and see what kind of overheads these maintenance tasks are getting, and then adjust accordingly. Max connection specifies the maximum number of concurrent connections that are allowed to the database. Every connection that is created with the database has its own overhead because the CPU needs to multi-thread through these connections, and there's a certain amount of memory that's allocated to them. A typical rule of thumb is to go to a max of 3 times the number of CPU cores that are available to the database, because a particular core can probably reasonably multitask through 3 connections. Anything more than that, it would be too much multitasking and too much context switching. So that is how you can set max connections. Auto vacuum. This is a concept that in my experience, experts that are coming in from other database technologies tend to struggle with a little bit, because this implementation is fairly unique to Postgres. So this is related to how concurrency is handled. Both Oracle and Postgres do phenomenally well with concurrent operations. So much so, and they're head and shoulders above other databases out there. Both do phenomenally well, but both have very different implementations of handling concurrency. How Postgres does it is through what is called MVCC, which is short for multi-version concurrency control. And why auto vacuum is important is that with MVCC, every session, if they are doing some kind of an update or insert, they hold a snapshot of the database, and that snapshot is held till the transaction needs that particular data. Once the transaction is done, that snapshot is released, and that copy of the database, or that snapshot, is labeled as a dead tuple, i.e. a tuple that is no longer required. Auto vacuum process is designed to clean up the dead tuples as transactions release their snapshots. And it is extremely important to allow the auto vacuum process to continuously remove those dead tuples, because if they accumulate, they will cause bloat in the database, and they will severely impact performance of your database. So yeah, auto vacuum is the setting that enables the process to clean up dead tuples. It should always be on. Please do not turn it off unless you have deep expertise in MVCC and how auto vacuum works in Postgres, and you know exactly what you're doing.
It's almost a part of transaction confirmation in Postgres in a way. So the mechanism, I mean, by which you just described. But I mean, if I may ask, can you, is it possible to give a really quick example of when auto vacuum is should actually be off? I mean, you say, please don't do this unless you're an expert, which I think you're probably the biggest expert in the room, Umair. But could you give us a really quick example as to when this could be a setting to turn off?
One example is, let's take the example of banking channels that run batch processes, right? So there might be a day end batch process that they execute, or a month end process that they execute. Mm-hmm. During that batch process, there might be a bulk of data that needs to be loaded into the database, and loaded very, very quickly. And in order to optimize that loading, you want to make sure that all kinds of overheads are taken care of and disabled, right, during that process, so that the data very, very quickly gets loaded into the ingestion is fast. So temporarily disabling every maintenance activity that might hinder or that might consume resources of the batch operation, and allocating every available resource to that batch operation may be a wise thing to do to improve the processing and the ingestion of the data. And in the course of that insertion, whatever dead tuples are created at a later point in time, vacuum, we can enable vacuum again, and it will then, remove those dead tuples. So that is one, way to, or that is one reason why you could possibly think of turning auto vacuum off temporarily.
Like extreme optimization scenarios, basically. Yeah.
Right, exactly.
Right.
Now, the reason why I typically say, please never turn it off is we encounter very frequently situations in production where, there are performance problems and we're brought in to investigate why performance has degraded, right? And one of the first things that I typically do is to take a look at the number of dead tuples in the database. Very recently, I was brought into such a situation, and I found that the ratio of dead tuples to live data was 3-1.
Right.
And I asked, how that could happen, and I started looking at the configurations only to find that auto vacuum was turned off. And when I asked why auto vacuum was turned off, I was told that, well, it was taking up too many resources, and we wanted to speed up our operations, so we just turned it off, and then we forgot about it. So
Yep,
that's never a good idea.
No, and there's quite a few settings like that in Oracle as well. So yep, good trick. Just before we move off this slide, I just want to make sure that everyone gets an answer to a very simple question, which is, you're talking about some of the most important parameters here, some of the most important things to set. But I just want to be clear: if you don't set any of these, they all have default values, right?
That is correct. Yes, absolutely. You can, this is best practice advice. Take a look at them, understand your resources, and then set accordingly. But even if you do nothing and just run Postgres out of the box, it should run fine for most scenarios.
Perfect.
Okay. Moving on. There are some disk cost associated parameters in there. Now, these are not allocation parameters. These are parameters that give the query planner an idea about the cost it could incur for running a particular operation. So as an example, sequential page cost. This is the cost of accessing sequential pages on disk, right? Set it to one that's a benchmark that will create a benchmark of what the cost is for accessing sequential data. And then there is random page cost, which means that, sequential is when the data is in sequence and needs to be retrieved in sequence. Random, of course, is when you need different pieces of data from all over the place. For spinning disks, the random page access is probably going to be very expensive. So the best practice is to set it high so that the query planner knows that accessing random data is expensive and it will try to maximize the use of indexes. If you have SSDs, you can lower that number to as low as 2 so that, the query planner knows that accessing random data could actually be significantly cheaper than spinning disks. And for some premium SSDs, I have even gone as low as 1.1, which makes it very, very close to accessing sequential data. If the disk is very, very fast and a premium grade, you can set it to that level, allowing the query planner to associate a low cost to accessing random data. Right? This is just helping the query planner do its job, depending on the kind of resources, hardware resources that are available to it. Moving on to pghpa.conf, this is the configuration file that is related to security. It specifies on different lines the kind of connections that are available and that are allowed to the database. The pattern or the format that is used is there in green right here. You specify the connection type, the database, the user, address, authentication method, and then there are a few options. You can specify who can connect to the database and how they can connect to it. The connection type parameter specifies, whether it's Unix sockets, it's TCP/IP with or without the transport layer security and SSL. You can specify in a particular connection string, you can specify the database and the user. So you can specify this connection, this access protocol at the database level, at the user level. You can also specify all databases and all users if you want to do a catch-all kind of a bucket. You can specify the address that the client is allowed to connect from. So this is an added layer of security. You can specify, a client is only allowed to access through a certain IP address or through a certain range of IP addresses or subnets. And then by default, the authentication method is trust. You could use trust, but please don't, because that will make it very, very easy for anybody to break into the database. And then there are different authentication mechanisms. SCRAM SHA-256 has been increasingly popular with Postgres users now. Very reliable way of adding authentication to accessing the database. You can also specify MD5 passwords and certificate authentication that you can couple with your organizational single sign-on. So a few configurations in there just to make sure that your database is secure. Next up, we're going to talk about disaster recovery. And the disaster recovery is essentially the ability to recover from a disaster in case the database is struck by something, how quickly you can recover from that kind of a disaster. It is defined by RPO and RTO. RPO stands for recovery point objective. RTO stands for recovery time objective. These concepts are common to all databases. So I imagine that this audience coming in from the Oracle background already knows about them. RPO is, the amount of data loss that can be acceptable to the organization, and RTO is the amount of downtime that is acceptable to the organization.
I can hear the grinding of teeth through the screen as everybody in this call goes, well, both of those are always zero, aren't they? Like that's what management always says. You have to have zero data loss and you have to have zero downtime.
Yep. And talk about HA, you want to have 100% availability as well. Absolutely. So it's only when you start digging deeper and start laying out, well, in order to achieve that, here is what you need to do, and here are the number of zeros that you need to sign on the check that you pay. So, and that's when reality starts to hit. But yeah, absolutely. Typically, anybody that we talk to, they start off with, hey, we want zero RPO and we want zero RTO. Okay, so this is what we'll have to do in order to achieve that. Okay, what is our next best option? And HA and DR, they tend to go hand in hand. High availability tends to complement our ability to lower the RTO and also the RPO. High availability, is more of a preemptive measure, and disaster recovery being more of a reactive measure. Physical backups in Postgres, that's one way for disaster recovery. It's a full physical copy of the Postgres database, including the data directory and the transaction logs. Everything is taken byte for byte. A physical backup is created. There's a built-in utility with Postgres by the name of PG base backup that allows for it. And then there are encapsulating tools that are made available to make this process easier. Some tools are, Barman and PG Backrest. Both of them are open source and freely available if you want to use them. It allows for an exact snapshot to be taken, and it also allows for a fast recovery time because, well, it's a physical backup, so the recovery is binary and byte for byte, so it's faster. The catch is that you need the exact same Postgres version on both sides. You cannot take a base backup of, let's say, version 15 and restore it in version 17 because the meta data and the catalogs are different between versions, and this is a physical backup. So both sites need to be exactly the same. So that's physical.
The other catch is that, of course, it's going to take some extra time to actually stand up the standby cluster as well, unless you magically have it available already. Typically, even if you have perfect backups on the same version, et cetera, you still need some time to actually stand up a cluster and then restore this data onto it.
Yep, absolutely. And that adds to the RTO, right? Because even if you have a backup that reduces the RPO, if you need to stand up a new cluster in order to restore into it, that adds to the recovery time objective. The next mechanism is logical backups. Again, utilities of pgdump and pgrestore are available within Postgres. And what they do is they do a logical export of all of the objects within the database as well as all of the data. The output generally is a standard SQL file that is human readable, that you can go in and edit as well. It's a logical backup. And you can use it for selective databases, for selective schemas and tables. And the catch here is, well, you can also use it across Postgres version. So you could take a logical backup in Postgres 15, you can restore it logically to Postgres 17, which you cannot do with PG-based backup. The catch over here is that this does not include the transactional logs, which means that this impacts the RPO, the recovery point objective, which in turn means that you can only restore up to the point where you took the last logical backup. The transactional logs cannot be restored or replayed.
Yeah, and it's also it's also quite hard to judge any possible data loss as well, because the nature of a logical backup is such that it doesn't like follow the integrity of the source, because it's essentially a data export. I guess I should say, just for I'm sure that everyone on the call understands this already, but I'll reiterate it just the same. So in the Oracle world, we typically talk about physical replication. We talk about physical backups, and what that means is that we're talking about backing up data that is consistent data produced by the database itself. So in the Oracle world, that's typically archive logs. It's typically redo and archive logs. Logical replication or logical backups is when you're actually querying the database to extract some subset of data. So it could be a single table in the database. It could be only transactions that meet a certain criteria. And when you're backing up those things specifically, so it's extremely useful in a huge variety of cases, but it doesn't actually like back up, quote unquote, the database. It doesn't allow you to have a stable, replicatable, stable state, as it were. It allows you only to have a backup of the data that you are specifically interested in.
Yeah. Yeah, and each has, as you correctly pointed out, Alex, each has its own use cases and pros and cons. You do get the option. By the way, the archival logs in Oracle, the counterpart in Postgres is the write-ahead logs, and which are replayed over the physical backup in case you want point-in-time recovery in Postgres, which we very briefly mentioned in the last slide.
Umair, we just had a question come through, and I was about to answer it, and then I thought, is this right? The question is, do pgdump methods, as you've got on screen there, do they also encrypt the backup files like as they're created? Now, I was going to say no, but there are additional utilities that you can use for that. Is that right?
That answer is correct. Yes.
Right.
So by default within pgdump, you don't have the option to encrypt the database as it takes the dump or as it takes the backup, but you can do it post-op, or you can use other utilities to encrypt that backup.
Is pgcrypto one of them?
PG Crypto is one of them. In case you have transparent data encryption with Postgres, which is available in a couple of proprietary forks, including, we referred to the Enterprise Postgres Advanced version by Advanced Server by EDB. TBE is available in that fork and a couple of other forks as well. So with TBE, it's transparent. Not only data that is available within the database, but also the backups that are taken. TDE is enforced in the backups as well.
Mm-hmm. Cool. Good to know that I know
Okay.
I know at least something that I'm talking about.
Yeah, you're giving yourself too little credit, Alex.
That's because I hang around. It's because I spend so much time hanging around with you. You see, you're starting to rub off on me.
Okay. To point-in-time recovery, we briefly touched on this in the last couple of slides. The idea is to restore the database to a specific point in time, and the combination of physical backup and write-ahead logs is what accomplishes it. So you take the physical, you restore the physical backup, and then you replay the logs till the point you want to recover to. So let's say the last physical backup was taken at midnight last night, and you want to recover to 6 a.m. In the morning today. So you'll take that base backup, restore it, and then play back 6 hours of write-ahead logs to get to 6 a.m. and then you have the point-in-time recovery. It's disabled by default. That wall archiving. It needs to be enabled if you want PITR. And there is tooling that is available to help ease the process of implementing PITR for your database. Barman, PG Backrest are example tools here. Critically important, and this slide is here simply because I never miss an opportunity to emphasize on this. Please periodically test your backups, always, because a backup is only good if you are able to restore it. Simply taking the backup is not enough. You need to test it out as well. You never ever want to get into a situation where disaster has struck and you find out later that the backup is not working. That would be a double disaster.
Yep, you're not joking. So as I said at the beginning, we're Dbvisit, which is the company that I represent here today, folks. We're a disaster recovery company, and yeah, I could tell you some horror stories. I could tell you some very, very big horror stories happening to people that should really have known better. But yeah, please, for the love of God, whatever recovery process you've got, whatever disaster recovery process you have, though it may not be perfect, please test your backups.
Yep.
Otherwise,
Absolutely.
you will discover that they don't exist, and even though you are really very sure that they did, but they don't.
Yeah. Absolutely.
Just before you launch into high availability, which is actually my favorite section. Good question. Another good question came up, which I don't know the answer to, which is in Postgres. Can you interrogate a dump file, like a backup dump file? Can you see what a particular dump file actually contains?
Right. So the logical dump or the logical backup is human readable. The typical output is an SQL file that is human readable. So you can take a look at the DDLs that it has dumped, the data that it has dumped, and you can even modify it before restoring if you want to.
Mm-hmm. Mm-hmm.
Yeah.
Cool.
Okay. Moving on to high availability.
I should just before you do that, Umair. So clearly a popular webinar, lots of questions. We've just added another 10 minutes onto the session, folks. So please do stick around. We're not going to cut out. But given that we're running a little bit over time, I might just let Umair get through the slides, and then I'll leave all the other questions to the end. Please carry on.
Okay, I will speed up my pace as well.
No, you're doing good. You're doing good. This is good stuff.
Yeah. High availability, again, a concept that is common to both Oracle and Postgres and pretty much all databases out there. Just that you need to remain operational, even if there is some kind of a failure of hardware or software. And typically, high availability is measured in number of nines, and this table over here represent what each of those nines mean, or the allowance of downtime per year. So 90% availability, while on the face of it, if you're talking to somebody and saying, our database is 90% available or 90% reliable, it might sound very good, but that's 1/9 of availability, and that allows for 36.53 days of downtime per year. 2/9 is 99%. That takes that down by an order of magnitude to 3.65 days. And then, for every 9 that you add, downtime goes down by 1 order of magnitude, till you get to 5/9, where downtime in a single year is 5.26 minutes. So 5/9 is 99.999% of availability. With Postgres, you can achieve 4/9 of availability using native open source community Postgres and its ecosystem. In order to get to 5/9, you need some specialized tools that are certainly available, but they are proprietary in nature. The way you achieve it is by that simple process of clustering. You've got a primary node, you've got 2 standbys with data being replicated to those 2 standbys. The application reads from and writes to the primary database, and all of that writes and reads and the updates are then replicated to the standbys. To the application, this cluster appears as a single server, right? And in case the primary goes down for some reason, one of the standbys can take over quickly, and the application can continue its operations. And that is, how we achieve high availability. And pretty much, very, very similar to any database technology that's out there. Just a visual representation of how it works. The primary goes down, standby 1 takes over as the primary. The replication paths that were previously from the primary to the 2 standbys are now from standby 1 to standby 2. You can add a new standby to this cluster in step 3, and the replication paths are updated from this new primary over here to what was previously standby 2 and this new standby over here. So that's essentially how failover works, and this is what achieves 4/9 of availability for your database. Replication, we've got both synchronous and asynchronous replication in Postgres. Again, the concepts are very, very similar across the databases. In synchronous replication, data is not committed till the replica has confirmed that it has received the data. So the entire cluster is always in sync. The data is always exactly the same. In asynchronous replication, however, the data may be transferred at a slightly delayed time, which is called a replication lag. And during that time, if you query 2 nodes in a cluster, there is a possibility that it will give you different results. Synchronous replication ensures consistency across all nodes, and asynchronous replication, there is a chance of data inconsistency or eventual consistency within the cluster. But asynchronous is also faster because the primary is not waiting for confirmation from the standbys, which makes synchronous actually a slightly slower operation, because when the application is committing data to the primary, that data then goes to the standbys, and the standbys confirm that they've received it, and then it gets committed to the primary. So there's a whole round trip involved, and there's also the process of committing to the standby that's involved that creates that performance overhead. Synchronous is generally used where data accuracy is of critical importance, even if it comes at the expense of performance. Asynchronous replication is typically used where performance is more important, even if it comes at the expense of temporary data inconsistency. The way physical streaming replication works in Postgres, you've got the application that's talking to the primary. That data goes into write-ahead logs, and the cluster is set up such that the primary has a wall sender configured that sends those records off to the wall receivers of the two standby nodes on these both sides. These wall receivers then create the wall records that are replayed on the standby, and that is how the standbys get data replicated to them. So a simple, a replication method, physical streaming, using wall records and wall sender and wall receiver. You configure it when you're setting up the cluster, and once done, this entire cluster then works in tandem. There are a few clustering tools that are available in Postgres for setting up this entire cluster and setting up this entire replication. Rep Manager, it's GPL 3 licensed. It provides for automatic failover, and you can manage and monitor replication using it. PG Pool has a license that is very similar to the very liberal BSD license, and it acts as a middleware between your application and the Postgres database. And besides replication management and automatic failover, it also implements connection pooling and load balancing. Petroni is another popular tool, MIT license, very liberal license, and it provides for automatic failover, replication management, and configuration management of the clusters. And well, Dbvisit has a solution for setting up this cluster for Postgres as well, and very easy to use GUI-based guided workflows that Alex can probably describe a lot better than I can.
I could, but I think given the time, we're not gonna dwell on it. Suffice to say, folks, that yeah, we do have a solution that's focused on ease of use. So as Umair has presented over the last 10 minutes or so, Postgres has a number of good DR and HA options available. However, as everything in Postgres, they can be a little bit complicated, especially if you're not already an expert in the field. So if you are an Oracle guy and you want to kind of have a look at a solution that other Oracle guys have created, that's where we come from, and our tool is pretty well known globally in the Oracle Standard Edition space as kind of your best option for disaster recovery other than Enterprise Edition. In fact, we kind of were well known as disaster recovery, as enterprise-like disaster recovery for Standard Edition. So we've introduced a tool for Postgres that really holds your hand, that kind of gives you a few good options for either having an HA style solution or a DR style solution, all with guided workflows and a good UI. There's a few questions that I've skipped over and haven't asked Umair because we're running a bit short on time around, is it possible to back up WEL files directly to cloud storage? How does HA selection work when you've got more than one standby during a failover? So these are exactly the sort of questions that our solutions answers really well, and kind of from an Oracle point of view. So I don't want to dwell on it here. This isn't a Dbvisit ad, but if you are interested, just click that link, and I'm sure we can get into it outside of this webinar.
All right. So we're going to move on and talk about the Postgres ecosystem.
By the way, Umair, we've got the lady in my ear tells me that we've got 5 minutes left. So do with that what you will.
Okay, there you go. Okay, so Postgres was created from the ground up for extensibility. It has APIs and hooks in place where you can add functionality in case it does not exist. What this has done over the past 3 decades, well, actually 4 decades, is that it has created a humongous ecosystem of extensions and tools that are available for using and extending Postgres functionality. Some popular extensions listed out over here: PostGIS, adds native spatial functionality to Postgres. When I first started working with Postgres, in 2003, at that time, the primary reason for moving from Oracle to Postgres was cost, but overwhelmingly, people would be moving to Postgres primarily to leverage the PostGIS extension because the functionality that it provides is very, very powerful. The Citus extension adds horizontal scaling capability, so you can kind of scale out your Postgres as much as you want to. Postgres Distributed, or PGD, is a globally distributed Postgres extension that can provide for active, or multi-master configurations. Timescale DB is another extension that is focused on IoT use cases and time series data management. PG Crypto enables data encryption for sensitive records. So this is all functionality that sits outside of the core DB engine, provided by extensions. Some popular tools: web-based GUI tool, pgadmin. Barman is for backup and recovery management. Petroni, we've talked about. HA clusters. Cloud Native PG is the Kubernetes operator for Postgres that is certified by CNCF. Oracle PG is a very useful tool that allows for schema and data migration from Oracle to Postgres. Fairly automated, the entire process. And this should be pretty much the last point. All popular cloud providers out there offer Postgres on their platform. We've got database as a service, as well as serverless versions on the 3 hyperscalers: Amazon, Microsoft, and Google. All of them offer this. And even the OCI, the Oracle Cloud provider, or the Oracle Cloud Infrastructure, has Postgres in their database as a service offering. So if you are choosing to deploy on the cloud, you have these options available. And that brings me to the end. A bit of a rushed end, but apologies, audience, for that.
Well, it's not for you to apologize, Umair. It was only rushed because people kept asking questions, which means that this is good stuff, right? People only ask questions if something interesting is going on. So well done.
Yep. Absolutely. Yeah.
Now, just before we let you go, folks, I think again the magical lady in my ear tells me that we have a poll that we'd love for you to participate in. And look, right on, we are like a finely tuned machine here, and you see it on screen right now. Please do offer up your feedback if any of this rings a bell. The best way to contact Umair is to either scan the QR code on screen right now, or to use the X link that he's got there, PG_Umair. A few people during the seminar, Umair, have asked questions that I think you'd be uniquely qualified to help them with. So I hope everyone's taking a photo of that QR code and getting back to you after this webinar.
Yep, absolutely. Happy to answer questions offline. We are out of time for the webinar, but happy to answer questions later.
I might just jump in here, Alex and Umair. Thank you so much.
We will be
there. Yeah, here I am. This is the magic lady. We will be sharing the recording. It'll take a couple of hours to generate, so you may get it a little bit later on, but we'll be flicking that through to you over email. And I'll also include Alex and Umair's contact. So if you do have any questions and you haven't scanned the QR code yet, or you're not on X, then don't worry, I will share the emails. So thank you very much, everyone. Thanks, Alex and Umair, and thanks everyone for answering the poll questions.
Yep. Thanks for joining us, folks.
Thank you.
If you've got any Postgres questions at all, Umair is the man to talk to. And if you're an Oracle guy and you just want to know how you can stand up Postgres DR as quickly as possible, get in touch with me.
There you go.
Take care. We'll leave you there, and we'll talk to you real soon.
Yep. Thank you. Thank you, Alex. Thank you, folks.